So, okay, let's get started. So, my presentation, this one, is going to be a pretty short one, at least I envisioned it initially in that way. So it's only one question that I wish to ask, and this is exactly the question in the title: does electromagnetism work in space? Perhaps you could add a subtitle like as it does on Earth, or something to that effect. But I don't know, from my experience, from my imagining, I think I can say that I'm the most skeptical person in here, but I'm not sure about that.
No, I'm more skeptical than you.
Okay, so
You're more skeptical than me.
The point of this discussion is really to provoke you, and not only for the sake of provocation itself, although I enjoy doing that, but also for the sake of, you know, inspiring some thinking on your part. And I hope that maybe some of you would have any ideas about what we're going to talk about. Okay, so basically, yeah, that's the question. Does electromagnetism work in space as it does on Earth? So I would say that you might, in general sense, say that on Earth we have a completely different set of conditions than in space, and with regards to electromagnetism also in particular. So on Earth we have, usually again, in laboratory experiments, in our power grids, etc., we have conductors, that is mostly metal wires and things like that, surrounded by large insulators, right? By the air, by whatever. Whereas in space, it's kind of the reverse, actually. We have small insulators, such as planets, maybe stars, I don't know whether they are insulators or not, surrounded by large conductors, which are space plasmas. And this is kind of a completely opposite, you know, upside down type of situation. So only that alone might create a lot of problems for us with our concepts of electromagnetism, etc. But that's not the only problem. There's also a problem of sizes, because on Earth we might say that most of the circuits are probably less than 10 to the 7th meters. That's well, let's say 10,000 kilometers. This is kind of the order of the diameter of Earth. We probably don't have grids longer than that, right? Whereas in space, so at speed of light, basically, this might be traversed in 0.1 second, or about so, even less actually. So yeah, but in space we have those intergalactic currents, and perhaps even larger currents, which might traverse distances of 10 to the 23rd or even more. So the situation again is completely different in terms of transfer of signals, right? So a whole bunch, I can imagine a whole bunch of nonlinear phenomena arising just from that lag. You see, we by the way already observed some strange effects in long circuits on Earth. It's a fairly known area of research, but in space it's much worse, like orders of magnitude worse. So perhaps it's actually like the way these electromagnetic signals are transferred in space is, you know, in a qualitative sense, something different, because the quantitative difference is so big, you know, so it may create some quantitative effects. Then we have the problem of momentum transfer. Like in earthly circuits, we have electrons mostly carrying the current, and the momentum carried by these electrons is negligible with respect to the circuit itself, because, well, they're light, they move very slowly, you know, the drift speed of electrons in circuits is of the orders of millimeters per second or about so. Whereas, so the circuit doesn't move, right? The electrons, their contribution of their momentum is negligible. Whereas in space, actually the plasmas themselves carry the current, and they carry their momentum with them. So it's a completely different setup in that regard. Also, there's no fixed framework in which the current flows, but rather the current itself creates a framework of its own, you know. So again, a completely different setup with that regard. So that's already sort of a starting point. And I was only talking about like regular electromagnetism. If we assume that it does work in space as it does on Earth, we still have all those problems, right? But then the problem arises with measurements of all these characteristics that we use to describe circuits on Earth, such as voltage, current strength, and things like that. Like in my presentation, I think I mentioned in Bath that you can't really measure in situ, let's say, voltage, the electric potential with a space probe, let's say, because the space probe itself is embedded in that plasma, so it would almost, like by definition, have the same electric potential. So I would imagine, like, if you want really to measure a potential difference between 2 points in, let's say, the solar system, you would have to have some insulating tube of sorts and kind of two detectors, like two Langmuir probes or whatever, in those different points. But, well, I mean, obviously, it's technically impossible if we're talking about distances of millions of kilometers. Then you may have heard, this is a slight digression, maybe you've heard about those space tether experiments in the orbit of Earth with space shuttles, and there were some mysterious things going on with them. So again, maybe even this thing wouldn't work. Alright? Okay, I'll skip that. I'll return to it at the very end. So the point was that even our concepts such as voltage and current strength might not be applicable, right? But in circuits on Earth, we have, you know, these basic circuit elements, and we have derived a pretty much, you know, standardized volt-ampere characteristics, that is the dependence of voltage on electric current, etc. So we have basic elements such as resistance, capacitance, inductance, of course the famous element of Jesus Christ, it's a line, get in the car element, and many others such as like diodes, transistors, but they are more complicated obviously. But what about space? Like, can we, I mean, some people have derived, for example, equivalent circuits for Earth, like global electric circuit. It seems like it works reasonably well if you take into account all the inputs, you know, from the cosmic rays, from the solar radiation, from whatever else. But what about space in general? Can we do that? Like, can we derive some, let's say, standardized circuit elements for double layers or Birkeland currents or molecular clouds or coronal holes? Like, we know there's like electromagnetic stuff going on in there, but how can we standardize it and make it, you know, create a black box that we can use and just, you know, draw a circuit of a galaxy or do something like that? I don't know, like, it may not even be possible with our current set of concepts. Then I've also marked here this problem of even the idea of a current as flowing from positive to negative, at least by definition. Is it applicable for Birkeland currents in general? I'm not so sure about that, because if you look at Don Scott's model, he actually has those layers of counter-directed currents, so you can't even tell that the current is flowing in that direction. It actually flows in that direction and in the other direction and in many directions in between. Yeah. So what can you do with that? Like, I don't know. So, like, the simplistic approach, I guess, just doesn't work, where we can say that, well, even those theories, you know, electric sun theory, where some say the sun is an anode, some say it's a cathode, I think it's an oversimplification of what is going on. Like, we might try to figure something out starting from it, but I'm not sure it really works, you know, in reality. I think we're dealing with something much more complex. Okay, so let's get back to that thing. And again, I was only so far dealing with, I was assuming that electromagnetism is the same in space in general. But what if it's not? And like, we might, of course, like, absolute majority of physicists tell us that the conditions in laboratories on Earth, let's say, are the same as everywhere else in the universe. But that's a very strong inductive statement, you know. And I'm not even sure if you can prove it even logically. Like, you know, we always have a possibility of black swan, you know. We might discover that at least in some area there would be different conditions, different constants, let's say, or something. Maybe you've heard, that's a pretty interesting story, how maybe 10 years ago or about so, some researchers have found that actually it may be that fine structure constant changes in space, and they've actually derived the direction where the change seems to be maximal. But I was just curious about the change. It wasn't very big, but it was like noticeable. But of course, it's based on multiple.
More or less than the experimental error, though.
Yes, it's based on multiple different assumptions, such as the distance estimates, etc. So you cannot just outright trust it and take it as fact. And then obviously there were many other papers kind of disproving that, right? But that always happens. We pretty much have this Maxwellian approach right now to electromagnetism, where, and by the way, it kind of relates to what Dr. Assis was talking about, this Weberian approach, which is completely different. So the British school of electromagnetism, it was mostly dealing with ether, really. Whereas the German school, they were concerned with particles. So they always tried to interpret everything on the language of particle-to-particle interactions, right? So maybe this type of approach would be better for space. Again, following Dr. Assis' talk. I don't know, like, but it seems like we might need to modify electromagnetism, even if it works as it is, just because as it is we cannot describe the thing. It's just the vocabulary is incompatible with the system itself, so we have to change our terminology, change our basic concepts, etc. But it may even be something else completely, like maybe our Maxwellian electromagnetism is only a special case of something else. I don't know. Like, this is exactly why I'm making this presentation, to ask those questions. And probably the last thing I wish to mention would be, again, even on the more fundamental level, like on Earth, in the systems we are used to be dealing with, we are pretty okay with this concept of object, you know, that pretty much was introduced in 17th century when the science was starting to envelop, so to speak, itself, where we kind of consider an object as being an inanimate closed system, where pretty much it is determined by its internal processes, all of its properties, right? But it seems, from what I said right there, that it might actually be not applicable to space, where it seems, again, following some research, that actually in space it's the external factors that are more important than the structure of the system itself. So our understanding of nature as a collection of objects might not be applicable in this case, because we cannot isolate anything, because external factors are more powerful than the internal factors. So there's no point in isolating anything, right? Or we might just, let's say, conditionally isolate some, again, border, some boundary through which the external factors kind of influence. And we can try to count them on their way in at that border. Maybe that sort of approach would be more applicable here. I don't know. But in general, this idea of externality, and by the way, it resonates very well with, again, Machian principles, etc. So yeah, it's definitely it seems to be a way to go. At least it's an interesting alternative path, let's put it that way. So yeah, it's a question: does electromagnetism work in space? Thank you.
Two comments, Eugene. First, the one you were talking about Birkeland currents, and can we talk about them going from positive to negative? I think you can create Birkeland currents in a plasma tube, so one could study that locally.
Yeah, but you see, this is one of the points I made, that you see, you introduce boundary conditions which are not existent in space. You have a tube, it's isolated, it behaves almost by definition differently than unconstrained plasma flow.
Well, still, but that
Still a
question,
plasma.
some is going this way and some is going that way. That phenomena can be created in the tube, so there's at least some insight to be gained from that. The second comment is you're talking about signal transfer. Consider the possibility that there's a longitudinal component of the Birkeland current, which could, who knows what speed it can go at. It certainly go faster than light.
Well, if you can create in a lab faster than light longitudinal Birkeland current, then we might talk about that, but I'm not convinced at all that such a thing exists.
Longitudinal force?
Well, there are longitudinal photons, but that only means the polarization. Basically, longitudinal photons transfer the electrostatic forces. Well, okay.
Right.
But what you're talking, I've heard this idea many times, and in fact I've discussed it with someone else here. I'm not convinced that such a thing exists. Again, like, I haven't seen any examples of that.
Well, a guy named Mile is doing experiments with longitudinal force. I forget, he's in Sweden or somewhere. M-E-Y-L. So something to look at.
Okay.
For you to consider. I'm not saying that
Yeah,
anything.
but anyways, that would be a different type of transfer of signal. Maybe it would have different properties. So the question remains, I believe.
We have Wal joined us, and maybe he'd like to explain longitudinal waves or signal. Eugene's not convinced they travel faster than the speed of light, so maybe you can tell us something.
Can't hear you.
We can't hear you.
Come here.
Give him a mic or bring him down here, one of you. As long as I can hear, I don't mind. Yeah, now he's got the mic and he's here.
Used to mic. I've just been climbing the hill. Having a look at a Tesla experiment, which uses the longitudinal wave, of course. And there's already experimental evidence, of course, from Constantine Mail, I think it's M-E-Y-L. Yeah, that shows that the scalar wave, as they call it, or the longitudinal wave, does exceed the speed of light. It all boils down to how is an electromagnetic signal sent from point A to point B, and the obvious answer is that it must be in the form of a wave, and to have a wave you need a medium, and the question has always arisen, what is this medium? Maxwell gave it some properties which are almost unbelievable. You know, they have to be very specific, and whatever the material medium is, it's not interacting with matter in any way which causes collisions and transfer of heat in the process. So it has to be, in my opinion, it has to be polarizable, we know, because the vacuum, as they call it, has dielectric properties. In other words, it can sustain an electric field. Now, I mentioned Dr. Horace Dudley, the radiation physicist, whose work I read back in the 70s. It actually came out of my reading of the Ponce and the Kronos journals, because they had a wide range of interesting individuals, scientists and scholars from around the world, who had taken seriously the challenge that Velikovsky threw down. But this guy was a radiation physicist, and he said that he felt that the answer to the problem of what is the material medium in the so-called perfect vacuum is the neutrino. He should call it a plenum of neutrinos. Now, working on the basis that Ralph Sainsbury's idea that the electron has structure and all subatomic particles must have structure, it has to be an orbiting type structure, according to both Wilhelm Weber's electrodynamic law, but also just to be able to explain the mass of an object. Because we know E equals mc squared, mass is an energetic variable. It must refer to the motion of particles, charged particles, within that subatomic particle, the proton or the electron, their motion relative to the rest of the fixed stars, as they used to say. In other words, to all the matter in the rest of the universe. Having that model in mind, it means that this polarizable medium that light travels through must also be material structure, it must have orbiting structure, and therefore I suggested that the neutrino is the most collapsed form of the particles that make up an electron and a proton, and that because it's in the most collapsed form, the energy of the orbiting particles is very low, and the internal energy is measured in an electron volt or two, rather than in megavolts. Now, I felt that it was necessary to have this kind of model because it fixes a couple of other serious problems in physics. And one is this idea that particles can wink in and out of existence. That is magic, nothing to do with physics. So the idea is then that a neutrino is involved resonantly with a nearby atom in such a way that it accepts energy from an electromagnetic wave of sufficient energy, that is up in the megavolt range, a gamma ray, to separate these particles, the subparticles that compose the electron and the proton, and it does so in a way that the charge between the two objects is different, their masses are different sometimes. In other words, you can produce either a proton and what's called an antiproton, what I call a mirror proton, or an electron and a mirror electron. When these particles appear to disappear, all of the energy that's been poured in to separate these subparticles comes back together again, collapses into a neutrino, and liberates the energy. There is no annihilation or creation. So that satisfies the key principle of physics. There was another aspect of physics which is unsatisfactory, and that is nuclear decay. It's a statistical process. In other words, that cause and effect are divorced. There is no cause. We cannot say why one particular atom in a uranium, a block of uranium, decides to suddenly split. So my suggestion is that a neutrino, because of its lack of charge and its ability to pass through matter almost as if it's not there, means that it can interfere in a nucleus of an atom. And if it came into, say, Ito's structured atomic model, at just the right point, it could be sufficient to disturb one of these stress points in the nucleus and cause that atom to decay. So you restore cause and effect.
Actually, a few years ago there have been a paper that have found apparently correlation between decay rates and neutrino flux from the sun.
Yes.
There have been such research.
Yeah, so that would be a kind of support for that
Right.
idea. What else was there about that?
How do we know the speed of light is as fast as you say it is from the longitudinal wave? Not the speed of light, speed of magnetism. A longitudinal wave, you say, travels from here, the other side of the day.
Yeah, well, let me explain how I think the two things work: the longitudinal signal and the or connection, and the electromagnetic disturbance. If you have a broadcasting aerial, which is upright, say, and it's transmitting, the field in that aerial is being reversed repeatedly. So, in other words, any polarizable material right next to that aerial will have to have its induced dipole rotate with that field. So the speed of light, in my opinion, is the measure of the moment of inertia of neutrinos, because the nearest one rotates, and it takes time because it has some mass, and then it sort of works its way through the ether, spinning it is the vortex, I suppose, that some people have suggested. That takes time. That's the speed of light, and it depends on the density of the matter that it's travelling through, because the neutrinos, being normal matter, will also tend to aggregate around stars and planets, and that gives rise to it's not gravitational, it's atmospheric dispersion of the light, so-called bending. Let me think, what else is there to say about it? Oh, the longitudinal force, on the other hand, is like a daisy chain. Because these particles, they have to be spherical, because they have to be spherically symmetric, respond spherically symmetrically to all of the matter in the rest of the universe. So, a neutrino, all of these polarizable particles can be distorted in multiple directions at once, but the one that connects point A to point B will have in effect the whole series of north-south, 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 like a string of magnets. And if you had such a thing, it would be like a rigid rod, so you could either push or pull, and the other end would feel it without that time delay. And this appears to satisfy the requirements of coherence in the solar system, because gravity must be pulling us towards where the sun is right now, not to where it was 8.5 minutes ago, where it appears in the sky. Biological systems must be in communication throughout the body and the mind instantaneously. Chemical signals and nerve signals are far too slow and could not coordinate all of the trillions of things that are going on at any instant inside a living creature. And so on it goes. For coherence in the universe, we require this instantaneous force. And of course, Weber's electrodynamic law does not include time. And that can explain the orbital system of an atom. In fact, it predicted it. For all these reasons, I think the neutrino, Professor Horace Dudley, back in the 70s, I felt intuitively was on the right track. I think that's about all I need to say.
Eugene, does that satisfy you as far as the fact it's faster than the speed of light or not?
So far, no.
That's a design experiment.
Well, we need an experiment, yeah, we do.
Yes, yeah.
You know?
Eugene, you asked a question, is electromagnetism a viable thing in the vacuum in space? I'm not exactly sure about the phrasing there, but what if we turn it around? What if the electromagnetism is the result of a material component, let's say just, I like atoms, the nucleus, the huge amount of empty space which you say resides within the nucleus. So my question back to you would maybe be, what if electromagnetism is a cause for the creation of the space, i.e. the empty space around the nucleus?
Well, I'm not entirely. Yeah, space. By space I meant space, not the abstract concept of space, but the actual space, the cosmos. So I'm not sure if your question.
Maybe that's just a scale factor, but a similar thing.
Yeah, well, I kind of see where you're going with this, but well, I don't know. Like I was specifically talking about large-scale things, right? So I'm not sure how the nuclei fit into it, although they should somehow, right? But I don't know. That's my answer. Sorry. Yeah.
But I always I'm struggling with all the things at the moment. Is it not like that? We can't imagine, or we have no feelings on our body or sensors that we were talking to get the feeling how empty the whole thing is, even on the level of an atom and outside.
Yeah, well.
So I have always the question: it's nice to have this idea. We have these elements, and what's outside? I always ask myself, what is outside? We are talking when a neutron is falling in parts and something goes away. The first thing is what this something is, but what's an outside? How it goes away from, where it goes, and how it goes. What we have bodies in mind, but what's around these bodies in reality? Not some models or something. I always have the feeling there is something. And when I heard about aether, when I studied the old Greeks and so on, then I said it's a model that goes much further than we are at the moment. What we are they thought there is something around us. Only to this.
Well,
It's real for me. It's what's yeah to get it taken. It's all a little bit like.
well, there's
Can
definitely.
we imagine it? What is?
Can we imagine? Well, we can, I guess. But there's definitely something.
I said yesterday. Perhaps we are children of this earth.
Yeah.
When you go in nature, if you have a plant, there is growing specifically on a place. They is constructed for this place, for the conditions and all, and we are constructed for Earth. So have we a mind that's so big that we can study these things that go outside?
Yeah, that's a great question. Yeah. I should have added that to my. But I agree completely with you. Yes.
So yeah, I'll stand up so people can hear the back. Eugene, you seem to have put two questions together. One question is the one physics, or different physics in different parts of the universe, and the second question is electromagnetism theory valid here, does it actually apply? Is it right? So now, the first question, I think you just have to think, well, okay, if you've got one part of the universe where type of physics A works and another one where type B works, what happens to the boundary? You see, if there's different physics to the boundary, it doesn't make any sense. So you've got to have one physics for the whole universe in the way we look at things, right? Now, is Maxwell's equations, do they apply everywhere? Well, logically, then yes, they do. It may be they are inadequate, it may well be, but you see, the important thing about them is they're scale free, curl H equals J plus dd by dt, etc. It is scale free, it'll work tiny, 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 and big, 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 big. And it also assumes the polarization of a vacuum, which is something we need, and it gives, c square speed of light, just comes out of it, and it's also Lorentz invariant. Now, there may be lots of things inadequate about that, but it's certainly
You're talking
that
about Weber?
no, just Maxwell.
Oh.
All that applies everywhere. Now, it could indeed be inadequate and modifiable, which I think is a fair thing to say, but what it modifies into would also be applicable everywhere, in my view.
Yeah, well,
Okay.
I would say that to me the key thing you said was in the way we see it, or something to that effect you mentioned.
Well,
But
we're not Martians.
yeah, but I mean our concept,
We could be.
our concepts that we have today, like
Alright.
the way we describe the world, our constants, if you like, our understanding of all those interactions, they are determined by our current experience. But what if we experience whatever the hell happens out there? And as you say, we might experience something completely unknown between some two areas of the universe. And we will have to maybe change our concepts through that. Because so far we haven't encountered that and we're okay with our current concepts. I'm just trying to go, I'm just trying to go as far as possible, you see, with this question. So
Alright, no, I think that's fair.
it is absolutely possible that we wouldn't encounter anything like that.
Okay. I'm almost as cynical as you. Skeptical, I mean.
I would just like to address or acknowledge that the idea of a closed system
Yes.
is key to all of this, I feel. And I actually, from my point of view, I do have a difference in my own understanding between a concept and a living idea. So that might put me in a strange place for you, but I feel a living idea is it has a universality. A concept is like a moment or a fragment or a static image, and that when we have our analogues and our formula, they give us a beginning place. So the wave gave us an analogue for the understanding of frequency. So we have beginning places, and it's like a breadcrumb trail, and I do see you on that breadcrumb trail in a willingness and good humour, and I appreciate that. And I feel that when you're talking about self-organising energetic systems, I just hear life. So I hear that, in fact, the whole universe is life. Maybe not as we know it, Jim, but it is life. And as we know it is a local universe, which is to quite a significant degree what we've been talking about, a kind of earth-bound or earth-formed or conceptual frameworks that we have, if you like, evolved as our self-conditioning experience. But just from me to you, and I feel that's...
Yeah, well, I can comment on that we don't even have a decent definition for life in science, I would say. So, maybe.
But does not life, in a sense, through definition, discover resonant reflections?
No.
And is that not what we're all doing in our own way, as resonant understandings, insights, intuitions? And they have form, and they have information, and they have structures of interaction, cross-fertilization, and dissonance and challenge. It's all part of the mix.
Yes.
Somewhat related to that is if we bring in Sheldrake and mind as being something other than physics, then physics is no longer a closed system.
Well,
I mean, the universe is no longer a closed system, unless you want to include mind.
Again, a fiction, a definition of universe.
yeah, so that's what I was talking about when I mentioned this externality. That maybe the whole concept of an object as a thing of its own in itself is just inapplicable in the universe as a whole. Because everything is connected and you can't isolate things, right?
Yeah, I mean, you talked about an object as something that is, okay, has boundaries, but is essentially a closed system. I've seen definitions of objects where I think I'm much closer to it, that just about the shape and the boundary. And that's about it. That's about what defines an object. And we have to be careful with the object definition here, because you might be too specific. Just the int.
Okay. Well, I might be. So?
That's the end.
I've got a much easier question.
Okay.
At the beginning you were talking about the effects that you see even on Earth at large scale. Can you give some examples of those?
Well, there is... Well, I'm not exactly well versed in that, but in the EU community, for example, at some lengths was discussed the so-called CATS question of how exactly, like if you have a long wire, not sure, maybe you know more about that. Like I just don't exactly remember.
Forrest
what the
Bishop
problem.
will probably know.
So if we have a plus minus and a very long circuit, so as the signal starts transmitting, like the question was, as far as I remember, what happens here, because it seems that if pluses go here, the minuses go here. So, like, the question was, I don't know, sorry, I'm kind of...
Well, the electron moves and the protons stay fixed in the
question was like, what
right?
causes this thing, and what's going on in here, actually?
And why does it travel at the speed of light?
Yeah.
Yeah, which suggests that the signal travels through the ether along the wire, like a waveguide, I suppose, rather than the electrons jostling, because that would take much longer than the speed of light.
And
then you've got induction around it.
Yeah, and obviously you can see that there's a lag, like current is already here, but it's not yet here. Like, for example.
That's right, yes. Yeah.
So that might lead to certain interesting effects at the very least.
Okay, that does connect. I thought it did to the fact that you were talking about the difference with a plasma in space, and you were talking about particles carrying the momentum and the charge.
No, that wasn't what I
No.
Oh, sorry, what did you say? I misunderstood what you said. You were saying about a plasma in space. You said a different situation.
Do you mean about momentum?
Yeah, momentum.
Yeah, so
Yeah.
I was saying that, well, in our wires, electrons carry like negligibly small momentum. So they don't impact the dynamic mechanics of the system, right? Whereas in space, it's actually the current itself that carries momentum, because those are the particles that carry the current, and they constitute the conductor itself, so to speak. So you have both current and momentum
Well,
transfer
you have charged plasma
in one
moving.
package, so to speak.
On your wire, a very long wire, you're sort of worrying about it. Well, I thought the standard description is, the long wire has just got an electric field in it equal to the voltage difference divided by the length of the wire, and then all along that field everything moves. Well, all the electrons move because they can, and the lattice is
That's
fixed
using the
positive.
field again.
It's a field, yeah. You have to stick a field in there
Yeah.
to do it.
What
Yeah.
we're looking at is the ether actually doing the job. The ether.
Okay, but the thing about electrons jostling each other, that doesn't come into this, because they all just say, oh, there's a field, let's move.
The electrons are distorted in that.
Oh, by the way,
Longitudinal field, they create the disturbance in the ether.
there was one thing I completely forgot to mention
Okay.
in my presentation, and that is the notion that we need a closed circuit. On Earth it is viable, but I'm not convinced it's viable in space.
No, you don't need closed circuits anyway.
Yes.
I mean, of course you don't.
Well, Alpha did.
Yeah, but if it's a plus here and a minus there, you can have a current going from one to the other. It doesn't have to come back again.
Well, there's the discussion.
Yes, you're right. That was the problem of what powers the sun continually.
Oh, yeah, okay.
Ralph Jurgens said that.
But we only do closed circuits because, we want the ring main to make it easier. But no circuit needs to be closed.
Yes, well, please finish that one.
Sorry, what?
Finish that thought, please.
Oh, okay.
Guys, oh, sorry.
Just quickly about powering the sun. One noted astronomer, Lloyd Motz, I think was his name, said that Jurgens' model wouldn't work because the sun doesn't hold enough electricity to power a flashlight.
Oh, right.
And also, if it did, that all the charge would rush in and neutralise it in a very short space of time. But as Jurgens and Hans Elfvén knew, they were talking about a circuit, so the sun is part of a circuit. So it's just like plugging your electric light in. The light doesn't go out as soon as shortly after you've plugged it in. The question then was, well, where is this circuit? Well, Elfvén actually drew it, but he used the sun as a generator rather than as a load. Jurgens considered it a load in a bigger circuit. In other words, the circuit wasn't looped around the solar system and back through the sun. It was connected via the Birkeland currents in the polar directions, which is the standard circuit arrangement for every star. That then raised the question, well, what keeps the current flowing? Well, Halton Art provided a clue here where he pointed out that these quasars are being ejected from the centres of galaxies with high velocity, very low mass, and low energy light output, which signified that the constants we had put in our physics textbooks here are different on these objects. The result of all that is that it's showing that the quasar is born electron deficient, and it spends its lifetime trying to collect electrons. And the first, after it's born, is connected by this umbilical cord, this current jet, which follows it. And the electrons trail along afterwards and catch up, and as they catch up, the electrical polarization in that body increases, its mass increases, and it slows down, its redshift decreases towards normal in quantized steps, as you'd expect if it's the matter that's responding to this effect. And the galaxy, after it's formed, is then on these long intergalactic power lines, which have now been verified. although they're not called power lines. And the whole shebang seems to be trying to chase some tail. It's like asking, you know, where does the current come from? That was asked at the conference, and I don't think the answer was satisfactory for the person who asked it, because I related it to this question of how did the universe begin and how is it going to end? I have no idea, neither does anyone else. It's like, I don't know where the current comes from, but I do know that plasma in motion of different densities and characteristics, physical characteristics, will generate the motion of the charged particles generates a magnetic field which induces a current in nearby plasma. And so the whole thing then boils down to, well, what caused the motion and what caused the ionisation or separation of charge? I have no idea. All we can do is work with what we observe, and all of the observations so far fit the plasma cosmology model. So that is the best we have at present for understanding the big scale picture. But as for the grander scale of all, the universe, who knows? That's for the future.
So thank you. Thank you very much.
Yeah, I just want to relate to that point, that returning to my idea that we might not need closed circuits, well, it's actually almost by definition any circuit in space would not be closed because of what I said earlier, because there would always be connection to some other circuits, whatever. Yeah. Thank you.
Right, go stretch your legs for a few minutes. There's glasses of water outside. Then come back in, and Jonathan Nova's going to say something.